this very excellent lecture series has come out of. This is part 2 of a 2-part series that Mark and Estella put on, and I'm just going to hand you straight over to Mark and he will introduce the speakers, so thank you.
Okay, joining us on this week's discussion is Paul from Health Habitat and our own David. After the presentation, we will continue with a panel discussion, which will include Yuri, and who is a sustainable designer from Newcastle. So just a brief recap on the theme of the series for anyone who's missed last week. We will be discussing how an evident and new strand of design has spread globally within the built environment realm, that is, design as activism. The role and the work of architects in the humanitarian sector has allowed the term humanitarian architecture to evolve. The numerous campaigns and non-profit organisations have been established to provide relief construction in the wider developing world context. It's important to question the relativity between temporary and permanent reconstruction and the balance between physical projects as a form of relief and the social knowledge exchange that constitutes the relationship between the organisation and the local communities in need. So I'll start off by introducing Paul. He's the principal of an architectural practice based in Sydney, and he's one of 3 directors of Health Habitat who work in Australia, who have been working in Australia for the past 30 years and more recently have expanded internationally. The work of Health Habitat has been acknowledged in Australia and internationally. Okay. Thanks, Paul.
Yeah, just the mic.
Yeah,
so
sure.
I'll clip you in.
Click on there. Beautiful. No, it's better if it's off. Okay. Hi. Nice to see you all. Look, I'll start by one thing I'll address straight off. The humanitarian architecture tag I'm always really uncomfortable with, because it sort of makes it sound like a worthiness factor, which I really don't like at all. This is architecture, I think, or it's not, but it isn't worthy. It's hopefully just the same work as I do in my practice or anywhere else. I just want to talk today about where the work started in Australia, only because I think the principles in that are what we've then taken overseas, and they're really what's important. It's the principles and then the specific examples, just to try and show you what those principles look like. This work started in 1985, and I won't go through all the history, those of you who've seen this before, but the key bit was all the work that we've been doing since then started not through a university, not through government policy, not through a bunch of white blokes sitting at a pub thinking this was a good idea. It came from an Aboriginal man who was the director of a health service called Yummy Lester was his name. And he saw that people were walking into his health service in Central Australia regularly. He's an Aboriginal man. Saw people walking into the health service and they were getting sick through preventable infectious disease. He saw that it didn't matter how many doctors you had, you were just treating the problem, you weren't solving the problem. So his brief to me and a medical doctor and an environmental health guy was to stop people getting sick. So the onus for this work came from an Aboriginal person who saw the problem. And that to me is critical. It's a fundamental bit of all the work that'll follow. The medical team came up with a health focus, and again I'm not going to go through these. If you want to find out about them, you can look them up. But it was a prioritised list of health issues that number 1 was more important than number 9. There's never enough money, never enough time, never enough energy, so you've got to prioritise. A lot of people don't like that, but we've found that's key in all our work. And all our work from 85 to now somehow has to fit with some of these health priorities. We don't go into projects where we're not delivering a health benefit, and the work we do is effectively health work, not housing work or environment work. We're unashamedly project-based work. We're not academics. We haven't done research for the sake of research. We're not a consultancy group. The work is really only as good as our last project, and we've done a lot of projects. In Australia, as of yesterday, we've done 213 places. 8,000 odd houses, 8,324, and about 58,000 plus people live in those houses. And we've tried to improve those houses from the first day we start. Why do we need to improve living conditions? Because as of yesterday, 9% of those 8,000 houses have safe electricity, 37% have a working shower, and 6% have a working kitchen by a standard, defined, repeatable test. This is an international disgrace. It's certainly a national disgrace, and it's a professional disgrace, how the architecture profession or any profession can sleep at night with those numbers in. We are now officially one of the richest countries on earth, and per capita I think we still win. So how can you have these numbers? Our work is not about showing the problem, our work is about changing it, and we insist on some immediate change within the first 24 hours of a project starting, on all projects, Australia and international. We have to make some change, meet the team, give them a toolkit, teach them within a couple of hours ways of checking and testing a house thoroughly, enter that information, licensed trades return that afternoon, house is a bit better the afternoon, the same house we started with in the morning is a bit better. Fred Hollows, the eye doctor, had a term, he said, no survey without service. You don't go in and tell people they're living in shit. You don't tell them their health's bad unless you have with you the means to fix it. And I think that's just such an obvious thing. I was at a conference last week, having just presented this, 3 or 4 PhD students and academics got up and proceeded to give an example of the work they'd done for 2 years, no return to any community. Nothing had changed. They defined how bad their eyes were, how bad their stomachs were, how bad their this was, how bad that was. No change. So everyone always nods to this, but they rarely do it, and that's a huge difference. And internationally it's an essential thing. Work with and employ local people, not lip service. How many do you actually employ? As of yesterday, 77% of all staff nationally. In Australia are Indigenous people. Overseas the number's more like 98% of everyone we work with, and often 100% are all local people to that place. Poor people should get the same design service as the wealthy. That seems to be, everyone would agree with it. Then how come we don't do it? How come international aid delivers a toilet that costs $50 and will last about 30 seconds, and yet they proudly proclaim they've built 10,000 toilets? Well, clearly what they've built isn't a toilet, it's a piece of rubbish, and they can claim it as something they've achieved. In fact, it doesn't solve any health problems, therefore it isn't a toilet. If a hot water system's leaking, like this is, because it's in an area where the mineral salts eat hot water systems, that's what it looked like inside. That was the element after about 3 months. Then you have to engage with a physicist who selects the best hot water systems nationally, puts them on roofs from top to bottom, and then data logs all the system so that we find out what's the best hot water system delivering the most hot water at the least cost. Why do we do all this? Because if it was we were working for BHP or we're working for a multinational, they'd probably want to know exactly these answers, so that's what we do. We have a team pretty much all the time we've been working trying to find the best tap in the world so that kids can turn it on and have a wash. That's not as easy as it sounds. There are thousands and thousands of taps, and only a few of them survive in Australia's old water, mineral water. We try and find the best shower rows. We try and put all this together, if we have to, into a prefabricated unit which you can put on a truck, ship and add to an old house or build as a core of a new house. And we hope this is the very best unit on the planet, not just in Australia. We'd hope this is the best designed and equipped unit that you can possibly make. And we upgrade it regularly to try and keep it the best. One of the reasons we're told, and I think our work has to address, is that houses are bad because Aboriginal people trash houses. And if you haven't heard that, you haven't lived in Australia. You go overseas, interestingly, and you use the same words for a different group of people. It works everywhere, it's an international. So you always blame the people, and that gets us, the designers, off the hook. So they're the categories we ask people to categorise. The licensed trades we have: fixing things, damaged, which it is, faulty, PowerPoint under a water point, great detail, not really a great idea, got to change it. And this one is a valve leaking, a routine. The salt water you can see is corroded and it leaks. So the proportions of the work we do, 70% plus is that, 20% is things that have been built upside down and back to front, and 8% is physical damage. Now we continue continue and continue to talk about that. There is still not one politician in the country who believes it. And I would argue 80% of the citizens of Australia would still believe that damage is the prime cause of Indigenous house failure. What's our job in all of this is to continually make that message. Our job is to remove myth. That's how I see it. We've got to actually puncture myths, and this is the way we can do it. Challenge orthodoxy and myth. We write all the stuff we do down. We've got it in a guide that covers the 30 years of work. We try and put all the results, the detail, the data, the design tips, materials, whatever we can do to help young designers, old designers do a better job. It's got a whole lot of sections. You'll notice the same 9. Whoops, that's a good look. It'll come back, won't we all? It's got a whole lot of bits in it. That's interesting, we've got a new format.
Are you losing information?
It's double screening, that's good. Try 20, 15. Yep, that's good. Okay, so it's got a whole lot of stuff in it. And we think that's important to record the results and have them out there for... Now this is online, so it's internationally available. Interestingly, at the minute, 70% of the hits on the site are international. Little interest in Australia, much greater interest internationally. Same issues apply everywhere. That's the work we do, and we believe you need a metrics of success. You need some measure of what is a good project result, and our measure is more houses working. One measure. So that's where those figures you saw I showed first, and that's where we get it to with an average budget of $7,500 a house. Not a huge budget by national terms. And we don't get these to 100%. Why is that? Because we're not perfect, and it's really, really hard to do. We don't get this much of a dent at all because our priority is back up in these areas. This is a lower priority. In a perfect world, these would all be 100%, and that's what we aim for. The other metric of success is to improve health. Obviously, that's what the program's about. It's very rare you can measure health improvement because it costs a lot, it's hard to do, and it takes a long time. It's been done once on our work independently by the New South Wales Government Health Department. They spent 3 years and $1 million doing this study, so it shows you how expensive it is. They looked at 2,500 houses, 2 and a bit thousand houses, 11,000 spent on each house. 75% of all the people doing the work were Aboriginal, and they got a 40% reduction in hospital admissions. And to us that was a key finding. It went to New York and London, was checked, came back, and it was published with that as the number. You're not medicos, I would guess, but if you got a 5% to 10% improvement by administering a drug, that would be front page news. To get a 40% reduction for about 1/millionth the cost is just unheard of. So what happened? The state government basically disowned it because they thought the result was too good, and people would ask what their other programs were achieving, so they didn't want to know about it. The federal government, the minister I took it to, it was in her bin 3 days after I gave it to her. She said, it's New South Wales, not relevant to the rest of Australia, so we chuck it in the bin. So that's Australia's response, I guess, to what we think is important information. We took the same principles and we've spread them to other places. And I'm going to really only go through one other place so I can concentrate on it. There's Nepal. We were asked to work in a village, a small village, one village, to provide toilets because people had no toilets. Not improve them, not check them, not test them, but provide them. So it fitted on our scheme of 9. Remove human waste safely is a pretty important one. So we said, yep, it's in the paddock. But we don't have lots of money, we're not a big aid agency, so the directors said you can't go without being able to offer something, so we offered 2 toilets, that's all. We'd design and build 2 toilets, see if people used them, see if they were useful, and then maybe see where we went from there. So started sketching the toilets. CAD drawings, I hope you noticed that. Who said an old dog can't learn new tricks? On lunchtime of the first day, with the first family I was doing those sketches with, We're invited to lunch in this house. When you go inside, they light the fire to cook lunch on green timber, and we're working for low caste, I guess the poorest of the poor in an already poor country. The only way they can cook is timber, and they scavenge timber, and most of it's green, so it puts out vast amounts of smoke. I couldn't take the photo after this had started because you wouldn't see anything. So you're in an enclosed room breathing in smoke and you almost die. That's how I felt. You asphyxiate. And we thought all of a sudden that's really as big a problem as the raw human waste on the ground. So we looked at solutions that already existed. We didn't have to invent it, but we had to find the right one and the right team. And there is a biogas system you can combine, human waste, animal waste, combine it. And off that you build it. And this was the very first lady who ever used biogas in this village. And you get 3 to 4 hours clean cooking fuel a day with no smoke. Our medical doctor's a respiratory physician, and he said the leading cause of death in this area and illness is not human waste. That does its damage on people's guts and many bits of them. The main cause of illness and death is smoke. And when I say you need metrics of success, we could have built the toilets, got rid of the human waste, but still missed one of the key, I think, metrics of success. You know, you're trying to improve health, so you've got to find this one and you've got to do something about it. And that's where we have to change. As designers, our job is constantly to think about ways of doing one thing and getting 4 good results, not 4 things and getting half a result. I always say that, you know, architects love taking pictures of the thing you can see. That's always the bit in the mags. And if you do these sort of whiz-bang, blown-apart drawings, they always get in the mags. If you show it as a humble dunny, it doesn't get anywhere. The bit, though, that does most of the work in this project is the bits we build underground, which get covered and you never see them again, biogas or septic tank. But the real bit we build, I believe, that the most important bit that projects build, whether it's in Australia or overseas, is the people who work on them. Most of these people were unemployed when we got to the village. Very few opportunities for low-caste people to work outside of farm work, cropping. So renderers, bricklayers, carpenters, they learn slowly. It's not perfect when it starts, but people get very good at what they do. And that's the sort of bit we never see that we actually construct as well. We also have to keep those toilets going for at least 25 years, and that's the aim of the project. Not to build a toilet and run, to build a toilet and make sure it functions perfectly for 25 years, because that's the health benefit. Building the toilet has no health benefit at all. Having it function has the health benefit. So local checklists without using words that people can, local women, it always seems to be women who are good at testing things carefully, not men. Men are hopeless. So this is the checklist of making sure all the bits work, and then there's a lady who's still 7 odd years on, has the toilet as good as when it was made. So there's a bit up the top you can't see, but after a few years of the program, we'd built 137 toilets, completed 3 villages, and this is what some of the families look like. And it's supported by people in Australia and overseas who just put small amounts of money to subsidise, not to pay for the whole toilet, but to help the family afford a toilet. And they're their names, they're the donors or the people who help, and they're the families. And I always emphasise in talks, these aren't poor Nepalese people, they're not them, they're not the poor. They have families, names, faces, kids, they're just like us. And the more we relate to that, I think that changes the nature of our work. Not humanitarian architecture, architecture for human beings that look like that. That's a much better description. Then in, early this year, 25th of April, the first quake hit Nepal, and the 3 villages where we worked had spectacular damage. That's a house, was a house. And you'll see in the background there 2 toilets. There were 2 houses, one's gone completely, this one's gone, 2 toilets. Another house, another toilet cascaded on by rock as the house fell down, but the toilet actually, apart from a bit of dinged roofing, was fine. Another toilet, they all have water tanks, so people were filling up water from the tank. And out of 137 toilets, 137 toilets survived. A miracle, a pure miracle that a house didn't actually take a toilet out. I wish I could say it was good design, but I think that'd be kidding everyone. It was magical, but the people there also thought that was pretty remarkable, and the local construction team are now gods, because whatever they build survives, and that's not a bad thing. Of course, then the serious bit of this is that we have 3 villages, many of whom, people within those villages we've worked with, they're our construction teams, they're friends, they've got nothing to live in. So step 1 was to get immediate shelter. Wet season was coming, they have 3 months of monsoon season, so before those rains hit, the urgency in May this year was to actually get some shelters that people could live in to keep them dry. That's number 1. Second one was to make sure that the sanitation, all the toilets did actually work. Not that they just stood up, but the tanks hadn't been fractured, hadn't been cracked in the earthquake, but they actually still provided benefit to people, waste systems and toilets, which they did. So we had to test each one, repaired some roof sheet, did some minor remove rocks repair, but basically they were fine. Those 2 people actually slept in their toilet. They put a mat down over the pan. They were short enough to fit in it, and they reckoned it was the safest place on earth, so that's where they slept during the aftershocks of the first and second quakes. Now it's become a toilet again full time, and they're out in their shelters. Second thing was to build a temporary shelter for cooking. Kathmandu uni students did 20 designs for cookers. We knocked 19 of them out, picked the best, and then the ladies of the village modified it with a sledgehammer. They adjusted the prototype, let's just say, bang, bang, now it's better. Now we can build them. So we've built about 110 of those, I think. A cooking shelter so that people didn't try and cook inside the living shelters where all the blankets and flammables were, so we put that outside. And also a very open shelter so the smoke doesn't kill people. We also did distribution of emergency stuff that people had lost, knives, cutting boards, mosquito nets for the wet season when mozzies come and spread illness. 180 families got kits of this sort of stuff. And then we knew that the houses were in horrendous condition, but then during the wet season, and what has happened is people safely demolished the houses, and that's all you can do in the wet. It's hard to build, but they can pull things down. And they started to stockpile rock, and they started to stockpile the timbers and all the stuff. And that's important, it's really important. Since the earthquake, I've probably seen 20 or 30 architect-designed new shelters that are going to solve the Nepalese housing problem. They all of them import material, all of them have brilliant ideas of refrigerated panels, paper tubes, you name it, there's an idea for it. Well, for the poorest people, I think that's not going to be possible. They have limited land. They're almost certainly going to have to build on exactly the footprint their house was destroyed on, and they're probably going to have to use the same materials, because even if you could afford to buy the materials, getting them down X thousand stairs or up X thousand stairs by hand won't be on. So we've looked at a system that takes the existing materials that have fallen down, recomposite them into a form that is earthquake proof or safer. I won't go through the detail. Needless to say, we've got stone and mud buildings where we put in key elements at key parts of the building, which engineers have worked on really hard for the last 2 and a bit months, 3 months, to come up with a system that's economic and that also can solve the problem of when buildings shake, they don't collapse. That also has to be, those things have to be taken to a human level. So again, we've got a system now where we measure up the person's house that they're going to design or they're going to map out. They're going to build it, we're not going to do that. A program quickly calculates the areas and the amount of this stuff we have to put in, and we've got a contract produced that the family then signs. They sign a contract saying, we agree to build a house that is this sort of shape and size. We will, Health Habitat and our backers will then put in the amount of money that covers all the earthquake proofing bits. Not the whole house, but just the earthquake proofing. So if you want to build a safe house and I want to build a dangerous house, we both end up spending the same amount of time and money because the safe house is being subsidised by Health Habitat. We've got 3 families ready to start, and then I think as winter approaches there's going to be many more families, and we've now had 2 other regions of Nepal coming to us to see if they can borrow the kit and do exactly the same thing in other regions. We're not going to be running it or in charge of it. We'll give them the kit and all the bits and say if you can do it properly, it's yours to use. That's the future of Nepal and always is on all projects. And I'm only going to touch 3 slides and I'm finished, but just to say that whether it's one of the richest countries in the world, in Brooklyn, in New York City, where we worked on are working on, 4,500 units in a really tough bit of Brooklyn, The team looks pretty much the same. They got dark skin, similar to Aboriginal people. I said that to them, they weren't impressed. The main thing they said was, "You got black people in Australia? That's amazing." And they wouldn't believe me. No matter how many photos I showed them of our teams in Australia, they refused to believe me. So the same people live in these apartments, they join the work team. On day one we had tools sent in advance, we were ready to start fixing on the first day. You wouldn't live in this joint, you wouldn't survive with my colour unless you had a local team getting you in and doing the work. You'd be shot dead. So it's a really good reason to have a local team. It's called survival. The second, just to give you, if you want tough. This is 250,000 people living in about 1.2 square kilometres in tin sheds on the edge of Johannesburg. If you think that's tough, 5,000 people a month want to come and live here from all over Africa, because this is the foothold into work in Joburg. So every month 5,000 people lob on the doorstep, and they're getting these xenophobic riots, they call them, where these people want these people dead because they don't want them stealing their jobs and their wives and their girlfriends. So this is constantly in, torment. I think it's a really, really tough place. In the midst of this, you have these local heroes, African group, who contacted us and contacted Health Habitat and said, "We fix toilets, we try and combat cholera and typhoid." That's their two illnesses that continually rack this place. These are the toilets built after the apartheid era to keep these people pacified. They don't work, they leak. So this is the teams, and we bring in skilled plumbers to help, working with local team, two of the local team, and we try and turn this into something just a bit better. We don't replace them, we don't have the money for that. We try and improve and get these guys and gals, 2 women, 2 men in the team. The other woman's taking the photo. They planted a garden at the end of this to try and any washing water when they wash the toilets goes and gets collected there, not out onto the street. And we started with 10 toilets, and as you see, we're a bit like a cancer, we spread. And slowly now there's a plan to just keep rolling it out, get more members onto the team of this team, get real wages, and keep rolling the toilet upgrades out. And then they maintain, which has always been their job, they maintain the toilets. And to leave you on the toughest problem that I've come across, and the one we're still grappling with, is in Ethiopia. The Fred Hollows Foundation has been working for 7 years. They have a full Ethiopian team of eye doctors, nurses working in Ethiopia, because they're trying to eradicate this bug called trachoma. And if you look at the green, that's one state of Ethiopia, not the whole country. They're targeting that one green state is their first target. In that state there's 30 million people, 15 million of them have trachoma today, and a third of those people will be blinded by the age of 20 by that bug. 10 million people. And if you want to have a sobering look at numbers, think about that one. When that was put to me, I found the numbers impossible to believe. Our job, the eye doctors can do the surgery to restore sight, they can give antibiotics to stop the bug, but 6 years later, 4 years later, 3 months later, in some cases, the same people walk back into the clinic with the same bug doing the same damage. So as the chief surgeon said, we could be doing these operations from now to infinity, it's never going to change the problem. The bug is active and keeps attacking eyes. So our job, we're not eye doctors, our job was to look at the environment. So our job is to go in and look at removing flies which carry the bug, and how do we do that? Building toilets where there are none, because flies breed on the toilet waste, obviously, and that propagates the disease. It's also getting water. All of these kids at the minute have less than 2 litres per person per day for all their life, for drinking, for cooking, anything else. To get more water on their faces, to wash the bug out of eyes, we need to increase the amount of water. So that's a water engineer's job. It's a big job of many players all to work together to achieve a result. At the end of it all, our work will probably be invisible, and again, that to me is not the issue. The issue is the metric of success. Reduce trachoma rates by 99.9% would be a nice start. Smallest village to start in, 10,000 people, just to give you an idea of scale. 10,000 people to kick off. A huge issue. Any of you who are not doing anything for the next 30, 40 years, well, you can join us. That's about how long it'll take. That's just a summary. I think we redefine architecture. We could redefine it easily to say architecture has within its scope the well-being of people and places. Health is the focus of all our work in Health Habitat, project-based, immediate improvement, working with and employing local people, equal design for poor and rich. Poor need it more though, rich really don't need good design. We can give them any crap because they just get another one or they go on holidays. So I'm actually lobbying for really bad design for the wealthy. That's a joke to my clients, I'm just kidding. That's being recorded, I didn't say it. Record the detail and challenge orthodoxy. I think most of the profession, sadly, are absolutely caked in orthodoxy. We just sprout the same rubbish again and again. Sustainability is this year's word. No, it's not. Resilience is the new word. That'll be out next year. It'll be a new word. Action research was in a few years ago. That's out. All these words mean absolutely nothing unless they're backed by action. I'm not good at the words. And finally, develop a metrics of success. You need to actually know whether you've kicked a goal or not, and when you haven't, then you have to redo your work. And that's been a big learning experience working with medical doctors who say, nice job, lovely design job, hasn't worked. Health stats haven't changed, go back and start again. That's a very sobering thing for an architect. Websites of the Health Habitat and also the guide, if anyone's interested, they're the website addresses, you'll find them, no problem. Thank you very much.
Just inviting Dave up now, but Dave is an architect, educator, and researcher who has relocated to Sydney after living and working in New York for many years. He's a founding partner of Super Maneuver, and Dave is currently working with CSIRO in developing a material to be applied to housing in the refugee camps.
I have an incredibly unenviable task today for two reasons. One is that I think Paul is probably the most humbling person you could possibly follow in this forum, and I certainly am humbled by and inspired by your work, Paul. I really should have been the warm-up task rather than the follow. And the other reason is slightly unenviable because we're really in the very, very beginning of this project. So I hope two things. One, to try to give a proper sense that we're really just finding out what questions to ask. We're not going to give you a lot of answers. The other is to please, because there are people in the audience who know a lot more about this problem than me. Some parts of it I know a lot, but much of the part, maybe the important parts of the problem, I know very little. And so I really invite actually a lot of very tough criticism, questions, comments, and actually also ongoing conversations and collaborations where possible. This is a team effort, and you'll see the evidence of the work of the team, each person's contribution. So we've got Dr. Louis Kratzis, who's an amazing scientist from CSIRO, who's recently designed a flexible battery pack that's 9 meters waterproof and will hopefully help revolutionize electric car transport by putting all the weight where it needs to be. He's a chemist by trade, but a material scientist as well. Professor Geisha Just, who's from UDK in the University of Applied Arts in Berlin. She's director of the DR lab, but also is the ambassador to the UN for design. And her lab, among other things, is very, very interested in wearable technologies, integrated electronics into clothing and so forth, and particularly very human ways of dealing with that. So it's not about fitness and measurement so much as things like people who fall down and can then press a part of their sleeves and get remote assistance and so forth. And also dealing with different forms of mental illness. Ebba Waldor, or Franzen Waldor, is a textile designer. You see some of her amazing work in the session. Most of you will know Professor Benedict Anderson, who's a spatial designer. He's one of the leaders of the Interior and Spatial Design project here. And I'm an academic and an architect. You'll see. I put this slide in as a reminder to myself because so far the project really does reveal too much that those are the skills involved, and you will see some of the absence. So when your only tool is a hammer, everything starts to look like a nail. So some people on the team start to see textiles as the solution to everything. I, of course, see computational design and advanced fabrication as the answer to all problems. And I put this slide in to remind myself that of course we're all wrong and the problem will find its own solution, not necessarily from our skill set. So we may prove ourselves irrelevant to the task that we've decided to undertake. As a reminder of what we should be undertaking, the UNHCR of course has their own guidelines of what they think a refugee shelter should do. It's also worth noting that the UNHCR, as the refugee agency, don't actually like refugee camps. And so that part of this is that we are acknowledging that these do take place, but there may be better political solutions that hopefully make our work entirely redundant. We would love that what we're doing, yes, becomes entirely unnecessary. You've probably been reading those while I've been going, so you'll get a sense also as we go. The one that's not on the list is this idea of temporariness in inverted commas. It's a really, really important one, and also a really shameful one, as you'll see. So the reality of the temporariness of a refugee camp is that most camps themselves live for more than 20 years. Most people stay there for 12 years, and more than 50% stay there for more than 5 years. Not to mention the fact that there's almost 60 million right now, and we're at a peak of inhabitants of refugee camps. So far the dealing with shelter in those camps is a really, really important problem, and the temporary thing is horribly ironic, but a very real reality for two reasons. The first one bared out by this one, which I think is actually probably the best design I've seen for a refugee shelter, which are these, which are sandbagged earth, locally gathered materials, responsible, well-structured, really provide great climatic environment for the inhabitants, and got pulled down because it didn't fulfill the host country's requirement for impermanence. So even though it solves 99% of the problems, it doesn't exist as a solution with that criteria for impermanence, which is a political criteria. On top of that, the desire for transience or impermanence is also sometimes chosen by the residents, because if the solution is too permanent, that ends up being the thing that they're stuck in forever, and they don't get processed and put into the next option, which is what we really want, is actually to be put into an actual situation, not a temporary town or a fake town that's not even allowed to admit that it really is a town. Okay, so that was approach -1. Approach 0 is the most minimal and actually has a lot of appropriateness to it, which is simply the UNHCR TARPAULIN. So the TARPAULIN itself is distributed, and the structure to hold up that TARPAULIN is found in the local area based on what's available, and that depends massively on where you are, and has more or less, it's a more or less appropriate response depending on what these things are available. Anecdotally, we heard last week that it's quite common to find the TARPAULINs in the market, so they're also, some people say that's a horrible thing, others say that's fantastic because now you have cash so you can translate it into something else. So that it's desirable and tradable is not necessarily a bad thing, and it's something we're reconciling with our own approach. Approach 01, this is called Better Shelters, but it's most famously known as the IKEA shelter because of its funding from IKEA Foundation, and because its approach bears a lot of influence of the IKEA approach. The thing which they've done, which is clever I think, is that they've fulfilled actually most of the UNHCR guidelines to the letter, and they've done it very, very cheaply, depending on how you count that. For something that comes from somewhere else, it's quite cheap. So it's $1,000 is their promoted price, and it fulfills a few of the things. It's quite permanent, it has a lockable door, it has full standing height, it's quite good at keeping the wind out and withstanding impacts and so forth, and the panels are quite useful if you no longer want it. One of the things which I feel slightly strange, given that it's a modular thing, is I've never seen a photo of it being made longer or wider or anything else, which I'm not sure yet why they haven't exploited, whether there's some, I'm learning still all of the policies around, some of the bad design decisions are imposed by policies, so it may be about just equality, that everyone gets the same thing. And so their approach is flat pack, which minimises, of course, shipping costs. It's supposed to be assembled in 4 hours. They know it's IKEA. Even they claim it's actually 4 to 8 hours. And it's claimed to have no use of tools. It does have a lockable door, a small solar panel, and a small light, which is quite interesting. So that's a look at what it's like on the inside. Approach 2, origami shelter. This is actually not aimed at refugee housing. This is actually for military pop-up shelter. The benefits of this approach is that they've recognized that the costs around the shelter are not just in the initial materials, but around the system. So there's two things that this does to that effect. One is that it's flat pack onto a military-sized pallet, so it stacks very efficiently into the planes which make that, so you have less gaps. You're getting as many things as you can onto the plane. And the other is that it's actually much more insulating than the typical tents, and that's got a systemic saving of fuels, and not only saving of fuels but saving of the transporting of the fuels, which for military in remote areas is a really big deal, and both of those things are relevant to transport it in refugee shelters. They also deal with the fact that now that they've got a different kind of materiality, it's much more insulative, but also incredibly heavy, and so they have this kind of strange origami, but two people can do this, which is quite interesting, so by rocking and levering and so forth. Approach 3 is the DOMO tent. This one doesn't have too much to add to what's been seen in terms of the UNHCR approach. The only thing they do is they try to have quite variable performance in different orientations. So they take advantage of some of the things of tents, and you'll see how we do the same. Shigiru, of course, most of you know in this room, assuming an architectural background, will know of his work. He's got two very, very interesting contributions. One is to say, well, you know what, there's a lot of commodity materials, depending on where you are. We should try to choose to use those and minimize transport in general by saying, hey, if we have paper tubes in the area, let's bring them from close by rather than having some international central repository in, I guess, in IKEA factory. And so here we see the paper tubes famously. This one doesn't have it, but in other ones he uses the beer crates as a way to get up off the ground and to keep the paper safe from the water. It's again a flat pack thing. It's quite interesting that the sort of custom nodes could be the only thing transported a long way, and that the standard pieces work with those non-standard. And interestingly, he's also played the game with UNHCR. So I think that's what hopefully I'll try to get a sense of, that it really depends on the situation which of these approaches is beneficial. So all of these people are giving really genuine contributions. The last one is, for those of you who saw me lecture maybe 5 weeks ago or something like that, this is a reminder to myself. This was a lateral thinking answer by Elemental to the problem of social housing, admitting that actually most budgets for social housing don't afford an entire house. Also admitting that actually a lot of the people have currently built their own house. They have some skills. They have a massive incentive in order to improve their own houses. And if you saw the contributed social house as just the seed of something bigger and acknowledged and designed for expansion, you could get incredibly good returns on your investment. I think that's also true of refugee shelters. And so I don't know yet the answer to this, but we're trying to figure out how to see our work as a seed to growth from other places. The last one is to say that most of these things, if you talk about transporting around, it's actually the compressive elements that are the heavy and the hard parts to transport, and they're also quite prone to damage in the case of the very thin steel pieces of IKEA. So one answer to that, which has come from hiking tents, is to use inflatable structures. Inflatable structures are, of course, incredibly light. This, even for a single tent, competes on weight. It's still slightly heavier than the tents that we normally know, but if you think about the pump infrastructure being shared across many tents, then very, very quickly it can become much more light. It's also very field repairable, and there's a few other interesting benefits about potentially deflating a little bit to change the thermal performance. So we see, here's the other interesting thing, if what we're trying to produce is an approach, and we know that the climates are incredibly different. Air beams also have very, very many different approaches in terms of the percentage that you would have. So here's 100% air and inflation. And what the thing looks like is like a tea house by Kengo Kuma. See the cells? So you get a much greater insulation, much less breathability, of course. And then this is kind of a gradient scale of slowly decreasing the amount of inflation or the amount of compressive elements, flipping it over to skin, in this case fabric, and slowly being able to increase the amount of air permeability. This is where I alluded to one of the other really nice benefits of air is it's a very low-tech way to be tunable, to put a little bit more air in or a little bit less air. This is a project by some colleagues from the University of Michigan where what they're trying to do is make a semi-permeable enclosure that deflation is what changes how much air can or can't go through. So you can achieve full seal or quite a lot of permeability by varying the inflation. The other thing they've done is they've used a lot of one-way valves. So in the event that one thing gets popped, it doesn't break the whole system, but you can still just pump in one place for very, very, very easy erection. The other benefit of having air beams is that the whole structure in its assembled state can be flat packed, and there's no chance of having assembly problems or of having parts lost in transport. It's a real problem for the IKEA tent if the one key part, as you know, if anyone's bought an IKEA bed or something, that one key part is really frustrating, and I imagine if you're the refugee trying to put up your shelter, it would be infinitely more. Okay, so back to our team and what we've been doing apart from a sort of survey of all the different benefits. One of the things which we're very interested in is that if we can use commodity materials but with, in this case, industrial knitting and weaving machines, so again taking advantage, like IKEA, of economies of scale, of materials which are readily available, of machines which are readily available in all sorts of places around the world, although mostly in China, to be honest, all the knitting machines, then we could start to do things that are much more rich and unique, and we could invest heavily in the thinking behind the process and not the materiality. If we can be lighter, we can save on transport costs and try to spend that money back on the investment on the initial item. So spend it on the things that get to the people, not the means of getting to the people. So this is just a whole series of tests of multiple layering, different performances in terms of insulation, of stretchability and so forth, with the idea that we could have a single envelope with highly multiple and plural performance outcomes, not to mention extreme beauty and things invest in being special and not just solve the problem. Okay, here's a second set of tests. This is now being performed at the CSIRO in Geelong in their Advanced Textiles laboratory. The interesting thing here is what we're doing is using a monofilament. So again, a commodity extremely cheap, has the capacity to last more than 5 years in this kind of environment. It will actually be black, not blue. It's better at dealing with the UV rays. And this is using specific weaves in order to allow something to flat pack and then self-form into semi-rigid structures. So again, trying to find ways of minimizing material, maximizing the lightness, therefore, and having the most simple assembly possible. So if the embedded instructions are almost the material just behaving in its own way, then assembly becomes simpler again. Knitting, did I bring it? No, I'll bring it before the end of the day. This sample here. So this is one of the issues with knits. It's not typically used in technical fabrics or in structural applications like carbon fiber or so forth, because it's intimately woven and the fibers are very bent. So there's a lot of stretch that needs to happen before you get to where the yarn is actually taking any weight. So this approach here is saying, okay, well, we're probably going to coat the fiber anyway to get the waterproof. This is a special research coating which is a bit like Gore-Tex, so it's breathable and waterproof, and has quite a lot of gradings of that, the balance of those two things. But here what we're looking at is doing a knit, pre-stretching it before we put the coating, and then because of that pre-stretch we have a stable format, a stable and much, much stronger. So it's taking knitting and using it in a way where it will be more like a weave and won't be as prone to all the dimensional problems, which would be quite difficult to make a tent out of an incredibly stretchy object. This is starting to say, okay, how can we make our weaves with gradients for transparency? Obviously privacy is a really big problem, but so is daylighting in these tents. So at various different orientations we want greater or lesser permeability. And here starting to look at how the knits are already embedding the tubing, the cavities for the inflation and so forth. Various versions. We started out with the tubes doing a lot of work and we realized that just didn't make sense. It was far too hard to get the tubes in and out for field repair. It was fine, you could do it once, but if you ever had to get it out and do a bicycle repair. So in the end we're moving much more towards the kind of X-based, so just long straight tubes, easy to get in, easy to get out. Here's one that's a big question for us. We know we have the capacity. So this is looking at weaves with copper entwined and within a coating system, then we can have embedded circuits, embedded electronics. We think it's quite interesting, and things like this is CSIRO's developed highly thin shell printing technology of amorphous PV. So embedding all of these things we think is very, very interesting in terms of the service it would provide. We're not sure yet whether it's good or bad that this thing would become even more valuable. It's maybe great because when it's not useful you can go and sell it. For sure, having light, this is OLED, so again where a whole surface can become illuminating. It's flexible. So all of these things don't diminish the flat pack, and we think technologically we'll be able to integrate them all into one package. We're not sure yet whether the problem asks for that. And in the background, of course, my job is to deal with the various different stretches of the knit to figure out how, when this thing gets inflated, what shape will it really take? Will it provide maximum standing ability, and so forth? And how do we deal with this kind of half-inflated, half-stretchy fabric? This is our kind of current working section where we have 2 sets of embedded tubes. That helps to create a cavity between 2 skins. Each of those skins has quite different performance requirements. It's quite nice that this one is only on the inside, so it can be a kind of multi-filament, soft thing that your body touches. And the outer one can be much harder monofilament and deal with the harsher part of the environment. And some sort of images starting to see how that would shape with the inflation, and being a bit worried about that it's a bit too blobby, of course, and we're wasting a fair bit of space. So, and other ideas about making things movable, multiple shells, probably, actually we really think that having a fly roof would actually make a lot of sense. That why don't we shade the whole building from the environment? Most of the refugee camps we're looking at are in very hot arid climates, and so having a lot more shade and also dealing with the outdoor spaces as more communal we think could be very valuable, and dealing with the kind of multiple sizes and so forth. But obviously these things are extremely, extremely preliminary. Okay, so far from all of those precedents, from our initial studies, we've come basically with a whole set of aims and ambitions. We need to be light, that's to minimize transport, to make sure our investment goes to the people and not to the jet fuel. We want to minimize the processes during manufacturing. That's because most of these will be produced in places where, well, that's to maximize how transportable the ideas are. If we can just send instruction files for the complex part, which is the weaving machine, and the simple part is just to stitch together a spiral, then there's more chance that this can happen in more places in the world. We want to minimize the parts at the assembly stage. That's to minimize loss of parts, complexity and so forth. We think it's pretty easy, but it goes on the page. More breathable than IKEA, more insulating than IKEA. Both of those things are where that particular scheme really falls down. It has to be minimum 5 years or we're kidding ourselves looking at this environment. And then at the same time, if we're really careful about trying to solve these things, I think we can be beautiful. I think there's a lot of potential for being reconfigurable. We don't understand, but we have people in the audience that can help us. Why are the tents always put in rows with big gaps between them? And why are they all the same size? I have no idea. We hope we don't find a reason and we just change that. Seems like a logical thing to do. So some joinable, I think having some uniqueness, if everyone's been displaced from their place, to be able to say that's my house and describe it, I think has value. I'm keen to talk to people to find out if they agree, and then some other aspects. This is what the problem can look like. It's scary, it's horrible, it's one of those classic problems that is many people have had a go at. It's unstructured, we're not sure what the answer is. We think that's the place where designers should be. I think designers are good at ill-defined problems with not clear what the answers are. This is what's going on right now, so even though we do certainly believe that political solutions would be much better to make the problem go away, but while it exists, then I think designers should get in the fray. You can see what skills we have, you can see what skills we don't. If you have the ones you don't, please come and talk to us. Thank you.
Just looking at providing these new infrastructure, so in your case toilets or shelters, how do you consider the tensions that these might cause between communities? So one community has the asset while others don't.
Do I need this?
Oh, you don't? I can
No,
hold
I
it.
don't.
It should be all right.
Yeah, it's a real, I mean, I think that's a really big issue wherever we work. The reality is in our work we can usually only get, not only do we get to one community, we only get to, say, a few families to begin with in that community, and that causes its own set of tensions. And the only antidote to that is you have to have local people within that community. We work through a village committee. We insist on a community structure as the minimum to deal with, so that you don't just get, you get some representation of the whole village to make sure that they decide where the first toilets are allotted to which families. How you deal with one village versus the next village is a bit more complex.
Okay.
Yeah, I mean, last week I think we heard some really fantastic expose of the extreme complexity of this kind of world and environment. Right? Suzanne in particular really showed that equity issue is a really tough one. In a way, architects always face that, in that 3% of the buildings are done by us, and that's a real problem. So one answer to that is that we try to do public buildings so that more people can gain than the patron. I don't know whether there's an answer to that also in refugee shelters, that there could be a way of doing more communal buildings, more things that are being shared.
Could that be a reason as to why the camps seem to be so rhetorical? They seem to be the same all the time. So it's not a uniqueness to one person.
Look, to be perfectly frank, I don't even have a clue. And I think those sorts of questions we need a lot of help in answering. I would not try to stand on this panel and pretend that I really have any idea about the distribution question, and that's why I'm so inviting of more people to give insight into those things. Clearly we know something about textiles and some other things. We know very, very little about the politics of refugee camps on the ground.
Maybe Susan can contribute to that. Am I correct? The question was, how does the repetition come about in the distribution of dwellings in refugee camps?
Maybe like who gets what?
Yeah, or these guys are just I think you're just looking at the planning, looking at area shots of large refugee camps and going, what is the consistency of the layout?
I think you can count easily, so
You can count.
I think it is a count issue because you have to know how many people are. Well, because per
Oh,
family,
yeah.
I think it's a count issue. It's in many ways controllable. I think when you start adding on, so it's just like where you just add on another row. It's probably also thinking of food distribution and healthcare and other things like that. So when you want to find a family, you can say it's like fifth row, third tent on the right. So you don't have. You don't have any families.
Yeah. I mean, the story you don't want to hear is it's the same method we've been using in the organisation of populations of people since we cleared slums in the 19th century in London. It works. It works in organising populations of people. So the question is, for me, I would think, is if you want to introduce points of interest, you were describing on what grounds when you're talking about an emergency situation, where you're talking about immediate relief, as opposed to another set of priorities.
Yeah, and I mean, just from the reading we've been doing so far, you almost always are dealing in both. There's emergency, extreme emergency, let's make sure these people are somehow in shelter and warm or what we'll call or cool. And then there's 20 years. And somehow part of the problem, I think, is that we try to solve both of those problems at the same time. And we don't acknowledge the difference.
Maybe 20 years is a more recent thing, because it's when refugee movements became protracted, which is 10 years or more. That's what we consider a protracted situation. But they usually are always, as I said, temporary, just because that's how they're built, because we consider displacement temporary, with then ultimately solutions being found that you either get return home, which is the ideal solution, you locally integrate, which would be in the first place facade, or you get resettled. So 3 permanent solutions. And unless the 3 permanent solutions are not found, you stay displaced, whether it's internally or externally. And that's why it has to be temporary. Because, they can't make it temporary when there's no solution, and it signals no solution has been found. And the host country may think that you have started a de facto local integration, which they've been very fearful of, particularly thinking of Afghanistan, which was quite long in Pakistan, where they've started bulldozing camps down as well, they've been very long, just because they don't want to signal that it's quite okay.
Okay.
And that's the danger with having anything too permanent, is the signal to the host country, even if it makes sense, even if you know many population project Afghanistan and Iran and Pakistan as well. And they still are, but they bulldoze camps down.
I saw a talk from a wash engineer who was working in Eritrea, and his role was to actually take apart a refugee camp. Like he was part of the deconstruction phase of it, because apparently there's also the aspect that if the camp goes on for much longer than it's ever anticipated, that these is like a huge toxic issue. So there's like, there's like septic tanks and there's weird buildings that were built by some charity that don't really work and fallen down. And I think it took him something like 5 years to actually decommission the camp after the refugees had moved on. So I think that, the issue of temporariness is very interesting, like in the very long term, particularly those camps that end up going for 20 years and then what happens right on.
Yeah, would you say that, would you say that like the efficiency of any solution in humanitarian architecture would be quite dependent on replicability, like easy replicability within the community, and also intellectual property? Open source solutions could perhaps make more impact and address the issues of communities being jealous of each other, who's going to get helped first, who's second?
I think absolutely the snowball effect, or that if you want to affect change, by far the easiest way is to not make it all reliant on you as an individual to do it. So, I mean, Paul's a fantastic example of that with the publication of guides, how to, so forth. Also, in the model is through training of local people that still have those skills once it's gone. Clearly, we would see nowhere near as many dots on the map if Paul was the only one building the toilet. As good as I'm sure he built a toilet. I don't build them.
So how will, say, the tent structures, not the textile structures, how do you deal with intellectual property, or will you deal with intellectual property?
Yeah, it's a very good question. For me, the intellectual property that I produce, and actually this is true of all of the academics to some extent in the room, that we're actually paid to generate intellectual property and give it away. That is 40% of our salary as academics. Of course, there's an increased move towards us getting money in, and normally when the money comes from somewhere other than the government, it gets harder to then give everything away. In this case, the IP that I generate as the architect, or as one of the spatial designers in the room, it's probably not very defendable, so it's probably easy for me to continue to argue that it gets given away. Some of the coding technology, some other things, as spin-offs CSIRO may choose to use in another way, but CSIRO, even as an organization, are really dedicated to giving away IP as well. Most of their seed growth technologies, or so many things, are about affecting change more than it is about making money directly for the organization. So all of those things are definitely true. One of the huge problems I have currently with what we're doing is that it relies on machines that are extremely inaccessible, and a software paradigm that locks down those machines. So that's something we're dealing with. What could we do? Could we really give away the patents? When right now, if you take very literally, the machine we're using in, which is a fantastic machine, in Geelong, it's made by a Japanese company. And I was really excited going down to Geelong because I'm a programmer. I thought, oh, this is great. I'll be able to learn knitting machine language, and this will be great. And no, that's not true. You can't even take a file from another Shinoseki machine and run it on that one. It literally has to run from that computer to that machine. So that will become an issue if that's the way we go.
There's always this discourse between the low-tech and high-tech in our future in general, also with solutions today.
Totally. We normally try to balance high-tech thinking and low-tech materials and means.
Yeah.
So you do a lot, that's the bit that you can give away, the thinking part, and then they can go and buy cheap threads.
Yeah. I have just an idea like about the, these people are obviously in an extremely difficult situation, refugees, or people in Nepal, and refugees, becoming refugees in their own country almost. The only thing they really have, or asset they have, is the labor, very cheap, affordable labor. They often don't have jobs, they need jobs. Obviously, Paul's projects address this pretty well. They engage the local community. Would your project be able to somehow involve the labor of the refugees or of the people?
Yeah, we don't have the actual answer to that, but when I show the elemental slide, that's kind of the way I think of approaching it, is that you do some small seed, which is the bit that's hard to do, as the people on the ground, and you try to make that seed maximally provide infrastructure for them, the bit that they can do really well, whatever that is, right? So whether it's, yes, there's lots of, well, again, a really massively dependent situation. So if you're trying, I think our scenario is this, we're trying to continue the masquerade of being temporary, and that's part of the challenge to let them build on top of that, because the bit that gets built on top of it is probably going to look less temporary than the tent-like thing, which is, so that's a challenge. But in more disaster relief, then yes, you get this thing, it's on their head. It's got potentially it's got some electronics and solar panels and some other things that would not be available. And then they can build out a bigger shelter with more modest or more substantial probably means actually.
I wonder if the fly is an answer to that, right? Because it's the thing that can appropriate space around and join together different dwellings,
totally.
cluster into larger groups.
Now, I was just curious, the criteria you had to make it, and one of them was, of course, the post,
Yeah, what do you do after?
use.
Yeah.
But my point is also, how do you use that? Because we know that tarpaulin is heavily sold, right? They get into the refugees and they may put it on and on, and because they have certain income possibilities, so the question is that what it is? It can just be used for shelter, period. And my second question, would you say that then you would produce locally, it actually may be a benefit. Most host countries are poor. It's internal displaced where they're poor anyway, so they actually could be then, you could create something that has other usages than this, is that you rather than just refugee labor, that you maybe actually just try to then work with local private sector to start creating something that first goes to the camps, then later can be given to the country, which is a little bit of added benefit for hosting. I'm just not sure that's how it works. Or is it the issue of the patents, so we're having these machines even going in these contexts.
Yeah, I mean, this is this question of whether or not, for example, embedding the electronics in the structure makes it much harder to steal. You can't just cut the good bit out and take that away and sell it, but maybe that's also bad. Maybe we want to give them the thing that they can sell.
No, actually mostly it is because certain people sell it.
Yeah.
They control the campus.
Yeah. Well, in that sense, maybe it is good that it's quite embeddable. You would have to take the whole thing.
I think I would put that actually in the criteria, that you reduce that step and you would help them.
Well, I wanted to ask you, do we have time? Or?
Yeah, we've got
I
time.
wanted to ask you, what is your attitude or opinion generally on the low-tech, high-tech future?